Hello, my dear friends and followers. This is Abhishek. I welcome you to my channel Ayodhya Informative. In my previous video, I have solved some examples on nth term of the arithmetic progression. So in that, I have explained how to calculate and how to find out nth term, last term of the arithmetic sequence. So in this video, I am going to continuing with some more examples. So if you are watching my videos for the first time, don't forget to subscribe and share with your friends. Let's get started. Today's the first question is check whether 301 is a term of the list of numbers. So here there are list of numbers. They have given a list of numbers as 5, 11, 17 and 23 so on. This is the given list of numbers. Here the task given is we need to check whether a 301 is present in this sequence or not. So this is the term we need to check. This is the term we need to check whether this is present in this list of numbers or not. How to check whether this is present or not? Let's check. Let's see how to find out this number. In order to find out, first we have to consider nth term formula, that is a plus n minus 1 into d. Here if we are going to calculate a nth term, not a number of terms. So here n stands for number of terms. How many numbers? 1, 2, 3, 4, 5, 6, 7, so on. That is the number of terms. But here an is represented as a particular term. Particular term is referred to as an. Here an is, if we take an as 301, an is 301. Let us assume 301 be the an. And in order to use this formula, what are the required data? A is the first term. We want A and we want D. We have A, first term. A as the first term as 5. What about this D? So D can be calculated as A2 minus A1, A3 minus A2, A4 minus A3, so on. D will be A2 minus A1. What is A2 value? 11. What is A1 value? This is 5. 11 minus 5 is 6. Then C. 17 minus 11, it is also 6. 23 minus 17, it is also 6. Since AK, that is a common difference, is same, common difference is fixed between this consecutive numbers, hence this is an arithmetic progression. So we calculated D as 6. Now we don't know the value of n. We don't know the value of how many terms are present in this sequence. We don't know. Let's calculate that n. Now substitute all these values in this formula. What we get? D will be 6. Now substitute D, substitute A and AN. We have 301. I substituted value of an as 301. What is value of a? Value of a is 5 plus. We don't know the value of n. That's why I keep it as it is. Then value of d, we have calculated it as 6. Now 301 5 6 into n minus 1. Now solve this one. 5. If you multiply 6 this into bracket, what we get? 6n minus 6, 301, 5 minus 6. What is 5 minus 6? It is minus 1 plus 6n plus 6n. So this is the what we get after solving. Here we want 6n. 6n, keep it as it is. Shift this minus 1 to other side. What we get? 301 plus 1. 6n equal to 301 plus 1 is 302. Now we have to calculate only n. We want n. So that's why shift this 6 to other side. It will be divided. N will be equal to 302 divided by 6. Then 3 2 the 6. 3 1 the. Then after solving 3 151 divided by 3. 2 3 the 6. 2 15 the 2 1 the. This is the number of n. Means here n should be in the value, not in the fraction. N should be a value, a whole number. It should not be a fraction. So here n should be a here we have get a value as fraction. That's why 301 value 301 is not present in this sequence. 301 a value 301 is not present in this particular sequence. Why? We don't get the value of n as a whole number. We got the value in fraction. That's why a value 301 is not present in this sequence. This is the answer. This is how we have to solve this type of example. So let's move on to the next example. The next example will be how many two-digit numbers are divisible by 3? So if you consider from 1 to 3 so on up to 100, in this range we need to consider only two-digit number, two digit. Here a two-digit starts from 10 and ends at 99. So in this range, how many numbers are present that are divisible by 30? Sorry, 3. 3 or 30? 3. This is the question asked. So in this 1 to 100, in from 1 to 100 numbers, we need to consider only two digits number. So from that two digits number, we need to calculate how many numbers are divisible by 3. This is the question asked. Let's see how we have to solve this. Now, from starting 3, 3 4s are 12, 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. From 3 4s are 12, it will be two digits. From 12, 3 5s are 15, 3 3s are 3 5s are 3 6 are 18. So on up to 99 is also divisible by 3, that is 33. So last number. So this is the sequence we get. These numbers are divisible by 3. Now the task is, first we need to check whether this sequence is arithmetic progression or not. Let's see. Check the difference between these two. 12 plus 3, the difference is 3. And between 18 and 15, the difference is 3. Like this, everywhere a difference, a common difference is same. It is fixed in everywhere whole in the sequence. That's why we can say this is an arithmetic progression. Now the task is we need to calculate how many individual terms are present from 12 to 99. How? Let's see. We need to calculate n, not an. We have a last term. Observe here, we have a first term and last. we know the first term as 12 and last term an as 99 and the difference common difference as 3. A is first term as 12 and common difference D as 3 and last term is indicated by an as 99. All these informations we know. From using this information from this data, we need to calculate n. What is the formula comes in mind? That is an will be a plus n minus 1 into d. This is the formula to be used. Now substitute all these value over here and calculate the value of n. See, we need an. What is the value of an? It is 99 equal to what is the value of a? First term a as 12 plus n. That is the task. N. We don't know the value of n. Number of terms. How many terms are present? So keep it as it is. N minus 1. We have the value of d as 3. 99 equal to 12. 3n minus 3. Now 99 equal to 12 minus 3. What is 12 minus 3? It is 9 plus 3n. Is it? Now, so we have to calculate the value of n. See, shift this 9 to this side. Minus 9 equal to 3n as it is. So, this is the equation. From this equation, we need to calculate a value of n. Value of n. Now, 99 minus 9. What is 99 minus 9? It is 90 equal to 3n. Now, here n as it is 90 divided by 3. So 3 3s are 9, 3 1s are 3 3s are n equal to 30. So this is the value of n 30. Hence there are 30 numbers from 12 to 99. There are 30 numbers are present which are divisible by 3. Which are divisible by 3. So this is how we have to solve these type of examples. So this is all about today's video. In the next video, I will be continuing with some more examples on the nth term of the arithmetic progression. So if you have any doubt in this video, please let me know through the comment section and share with your friends. Don't forget to subscribe if you are watching my videos for the first time. Thank you.